Why Bach was the most mathematical composer in the history of music. I'm going to discuss that interesting topic here in this video. Recently, actually very recently, just a couple weeks ago, I published a book titled Tempo and Duration in the Music of Bach, Uncovering J.S. Bach's System of Tempo, Symbolism, and Proportion. This book is a nice spiral-bound edition here, very easy to read. It actually has a little bit of enlarged font, so it's very easy to read. This book took a total of over 30 years to research and write. So in this book, which is very, highly mathematical, I show how Bach organized his works the way he did. And it was very mathematical and very systematic. I'm sure that you've heard Bach's music before and you've thought, wow, this sounds a little more mechanical or mathematical than many other composers' music, like Chopin, for example. You have nice, beautiful melodies of Chopin, and then you have this sort of kind of more of a rigid approach, a strict rhythm and the Baroque style rhythm that goes on, and you have rules and formulas. Bach followed counterpoint rules, and Bach was all about rules, and Chopin was more about freedom. And the reason I'm bringing up Chopin is because I recently did a video on comparing Bach and Chopin. But let's get back to the mathematical aspect of Bach's music. The first thing that is highly mathematical about Bach's music is his tempos. Now, 30 years of research has led me to the conclusion that these were Bach's tempos. These were the exact tempos Bach planned for his music in this matrix. It's very interesting. When you study this matrix, you see that they're all interrelated. So all rows, all tempos within one row have a common note value, a fastest note value that's common, and then each row as speeds up or slows down depending on which direction you go, and then the columns are the actual groupings of the notes. And so you can see here that this is a perfect matrix of numbers that anyone could have come up with. This is not my matrix. I didn't invent this matrix. Neither did Bach. Bach didn't invent this matrix. These numbers existed long before Bach was even alive. So it's more of the discovery of how these numbers are all interrelated. Well, this sounds very Renaissance, because if you know about music history, you'll know that in the Renaissance period, especially in the 1400s, like in the 15th century, they were really striving to figure out how everything works together, like all the time signatures and the proportions and so forth. For example, there was a music theorist by the name of Johannes Tinctorus in the 1400s, and what he did was he tried to unite everything in a theory of proportion and show how time signatures are related and so forth, very much like what I show in here of what Bach did with his music. So in a sense, Bach was really, and he was living in another age. Bach used techniques that they would have probably used in the high Renaissance period or the earlier Renaissance, but Chopin would have never done this. So anyway, we have Bach's matrix of tempos. And so what Bach did was, before he composed a movement, like let's say from a Brandenburg Concerto, for example, which is our first exemplar we're going to look at. When Bach composed a movement, he first chose the style and the tempo of his movement from this matrix. Of course, I'm not saying that Bach had it all lined up just like I do here, but he had it at least in his head. He knew what tempos, what beats per minute speeds were related to other beats per minute speeds, and it all interrelates depending on the time signatures and so forth. So Bach followed a very strict kind of hierarchy of time signatures and speeds that were associated with those time signatures. This is a very highly mathematical concept. This is why it's mathematical. Like other composers, this doesn't even apply. You know, you can't say that about virtually any other composer. Maybe a few, Brahms perhaps, but no composers were as mathematical and as systematic as Bach was when it came to time signatures and the selection of tempos. So let's move on to an analysis here of Bach's Brandenburg Concerto number 4. Okay, so let's look at Brandenburg Concerto number 4. Here is the chart up here. And you know what I found in my massive cantata study? I studied 206 cantatas and analyzed the organizational structure just like we're going to do with the Brandenburg Concerto here. So I did this with 206 cantatas, and I found what I'm going to show you in this Brandenburg Concerto. Bach did similar things in virtually all of his cantatas. Not all of them this accurately, because I chose this because it's stunning the way that Bach achieved the accuracy in the Brandenburg Concerto number 4. So let's look at this. So we have 3 movements. We have Allegro, it's in G major, 3/8 time, 426 measures. DQ equals 56, that's dotted quarter note equals 56. And if performed exactly at dotted quarter note equals 56, that's 56 beats per measure. If performed exactly at 56 for 426 measures, it should last 7 minutes and 36 seconds. So you can do that by calculating it out. So you take 426, and you go divide by the tempo, divided by 56, equals 7.6071. Okay, now take away the 7, multiply by 60 to give you the seconds. So that's 36.426. So in other words, 7.36.426 seconds. 7.36 seconds. So we can just say 7.6 minutes is this. So if performed exactly at 56 beats per minute per measure, the first movement of this will last 7 minutes and 36 seconds. Now, the Andante, next movement, E minor, 3/4 times, 71 measures. If performed at an Andante of 63 per quarter note, if done exactly at 63, it will last 3 minutes and 22 seconds, 0.85 to be exact. And if performed, the third movement is a presto in G major, 2/2 time, 244 measures. If performed at 96 beats per measure, as comes from the tempo table also, it lasts 5 minutes and 5 seconds. Now, why is this a big deal? Well, it's a big, look at the numbers. Look at the numbers. Okay, take 7.6, which is 7 minutes and 36 seconds. Okay, so let's take 7.6. Okay, it's easier to just work with 1 decimal, okay, than with all those fractions. Okay, 7.6. Now we're going to go times 2 divided by 3. Okay, it's 5.0666. Okay, so I'm going to take away the 5, multiply by 60 to give seconds, 504. So you can see 2/3 of 7.6 is 5 minutes and 4 seconds. Okay, so there's a exact 3:2 ratio. It's just off by 1 measure. See, had Bach composed just 1 less measure for the presto, 243 measures, it would have been exactly 5 minutes and 4 seconds. Now, Now let's look at the Andante, number 2, the second movement. So not only is the first and third movements related 3 to 2, but at 63 beats per minute, the Andante, the second movement, lasts 3 minutes and 22 seconds. Well, it's actually 322.85. So I just discovered something too before I was doing this video. See where it says 322 on the right column? It should be 323. So change that 2 to a 3. See, I should have rounded off 322.85 to 323. So because here's the deal. If you take 23 divided by 60 equals 0.3833 plus 3 equals, okay, so 3.3833, that's the decimal value of 3 minutes and 23 seconds. Now I'm gonna take times 3 divided by 2. Times 3 divided by 2 equals 5.0749. Okay, so take away the 5, multiply it by 60, and you get 4.49, like 4.5, like just 4 point something. Okay, so 504. So you see 323 and 504 are at a 2 to 3 ratio at the same time as 736 and 504 are at a 3-2 ratio. So the first and third movements are related 3 to 2. The second and third movements are related 2 to 3. This is not a coincidence. Bach planned this. So what he did was, he obviously the only way he could have done this is by choosing the tempo first and then calculating out how many measures he needed to attain those particular proportions. It's really that simple, because you can't do this by chance. Maybe you can do it once, but you can't do it hundreds and hundreds of times like he did in his music. So let's look at another example now. This is this next example I'm going to show you is the absolute most freakiest thing you'll ever see in your life. This proves without a doubt that Bach was the most mathematical composer in the history of music. So let's turn our attention now to the Confiteor and Sanctus sections from the B minor Mass. Okay, so in the B minor Mass, which consists of, I believe, 24 movements, movements 19 and 20 are called the Confiteor and the Sanctus. So the Confiteor section is subdivided into 3 subsections. Okay, and then that's movement 19. So movement 19, 3 subsections, and then movement 20, the Sanctus, has 2 subsections. So we have a total of 5 subsections and 2 movements. So we have 3 here and we have 2 here. I mean, that's not a big deal in itself. We have a 3 to 2, but that's just the number of units in each one of those movements. But here's where the really interesting and really fascinating and astonishing thing happens. So what Bach would do, as I explained, is he would choose his tempo first and then figure out how many measures to write in order to achieve whatever duration ratios he wanted. Well, this is really fascinating. Okay, so let's look at the Confiteor. We have the first section of the Confiteor does not have a tempo indication. The second section is marked Adagio, and the third section is marked Vivace et Allegro. So we have a very slow middle section and a fast outer section. The Confiteor, I think, works best at a moderate speed. So let's assign it a moderate tempo, like something in between the Vivace and Adagio. So Adagio is here, the Vivace is here, and then the more moderate Confiteor tempo is maybe here, like somewhere in the middle, okay? So let's do that. And it works really well. So let's select 70, half note is 72 for the Confiteor. Let's select half note is 48 for the Adagio. And all of this lines up with this tempo matrix here. And the vivace here, half note equals 96, just like the last movement of the Brandenburg Concerto number 4. So, calculating those out, if performed exactly at those tempos, you can see that the three subsections of the Confiteor consist of 120 measures, 25 and a half measures, and then 105 and a half measures. So if you calculate out exactly how long it lasts at those tempos with that number of measures, you get 3 minutes and 20 seconds, 1 minute and 3 seconds, or one like rounded off to 1 minute and 4 seconds. Then you get 2 minutes and 11 seconds. You can round that off to 212 because it's almost 212. So you get 320, 104, 212. Well, basically, if you add those all up, they add to 636, 6.6 minutes. Well, that's nothing to, big deal. Okay, so you're wondering, yeah, what's the point? Well, here's the point. Look at the sub durations now. Look at the sub durations. You see 320, if 320 were just rounded off to 318, okay, that's 3.3. And the Adagio, that 1.4 was rounded off to 104 was rounded off to 106, so add 2 seconds onto that. That's 1.1. And then the 212, that's 2.2. So you have the subsections of the Confiteor are 3.3 minutes, 1.1 minutes, and 2.2 minutes. And if you add those up, 3.3 plus 1 plus 3.3 plus 1.1 plus 2.2 equals 6.6, or 6 minutes and 36 seconds. Okay, it's really amazing. Look, the 3-1-2. 3-1-2. I mean, that's like as accurate as a Swiss watchmaker. Bach was only 1 measure off in the first section. Had he had 119 measures, he was only 1 measure off in the Adagio. Had he had 26.5 measures, and had he had just 1 more measure for just the first 2 sections of the Confiteor, it would have been exactly a 3-1-2 duration ratio. It would 3.3, 1.1, and 2.2, 3-1-2. Now, here's the really freaky thing. When you take the Sanctus and its 2 sections, you have assigning 84, a nice sort of a moderate to a brisk 84 for the first section, and then a 56, 3/8 allegro for the pleni suncelli. Sorry about the pronunciation, I get that wrong. Notice how the dotted quarter note of 56, that allegro is equal to the same allegro as the first movement of Brandenburg Concerto number 4. So it just falls in line with Bach's standard tempo. So if you assign the first section of the Sanctus 84 per quarter, the second section dotted quarter 56, and calculate those out, they will last, the first section will last 2 minutes and 14 seconds. The second section will last 2 minutes and 9 seconds. So, in other words, Bach was just 1 measure off from the first section of the Sanctus from achieving 2 minutes and 12 seconds, and he was 3 measures off in the pleni section from achieving 2 minutes and 12 seconds also. But the really freaky thing is, even if you don't round anything off, and if you add up the durations 214 and 209, it comes to 423, or like rounds off to 424. So Bach achieved exactly, the combined total of the Sanctus is 4 minutes and 24 seconds. 4.4 minutes. And it's subdivided as 1 to 1. See? 212, 212. So you have 212, 212, 424. Now, here's the freaky thing. Not only do we have 312 and 1-1, but the total durations, that when you add those up, 6.6 and 4.4 are at an exact 3-2 ratio. This is a miracle. This is absolutely incredible what Bach did here. This is the most highly controlled mathematical achievement that I've found in Bach's works. I mean, there are some other really stunning things, but this one here, I think, gets the prize for being the most ridiculously mathematical and systematic out of all of Bach's works. So let's just summarize this, the Confiteor. So we have movements 19 and 20 relate 3 to 2. And not only that, but the subdivisions of movement 19 relate 3, 1, 2, and the subdivisions of movement 20 relate 1, 1. Not only that, but it's the same, the 1, 1, the 212 and the Sanctus is the same as the 212 and the Confiteor. So he really has only like 3 duration segments he uses for all 5 of those movements in movements 19 and 20 and all of those subdivisions. It's really an amazing thing. This couldn't have possibly happened by chance. This was planned. This proves that Bach selected his tempo first, and then he calculated out how long the movements had to be in order to attain these ratios, because this can't happen coincidentally. So this, I think, really proves that Bach was the most mathematical composer in the history of music. This analysis of the Confiteor and the Sanctus just really take the prize. This takes the prize as the most highly controlled, just tightly controlled durations of time and proportions. This is highly mathematical. I don't think any other composer would have done this except perhaps in the Renaissance period. So thank you for joining me. This is a really fun video. I hope you got something out of it. Join me in other videos where I will discuss Bach's compositional procedures.